Okay, this is the review for Unit 6, which covers Chapter 10 and Chapter 11. So let's start with Chapter 10, circles. In number 1, we're supposed to find the measures of all these arcs here. And what they gave us here, these are called central angles, because they are angles that go through the center of the circle. Now we measure central angles, or we measure arcs, in terms of what the central angle is. So the central angles, whatever the measure is equal to the arc. So for example, this angle LPM is 40 degrees. So we measure the arc that gets made from that with the circle LM, that is also 40 degrees. So let's take a look. The measure of arc KJ, which is this arc over here. Well, I know that this angle MPN is 25 degrees, and since these are vertical angles, this angle is also 25 degrees, making that arc also 25 degrees. In the directions it said label the arcs whether they are minor, major, or semicircle. This is a minor arc. Minor arcs are less than half the circle, or less than 180 degrees. Part B asks us to find Jn. So now there's a couple ways I can go from J to N around the circle. I can go across the top, or I can go across the bottom. When they use two letters, when it's using two letters, we use the shortest distance across, and that's across the bottom. So I need to find the measure of this arc from J to N this way. Well, I can see that this much from K to N is 180 degrees. It's a half of the circle. This already uses up 25 degrees from that. So if I take 180 and subtract 25, I will get the measure of that arc, and that is 155. This is still a minor arc. Part C asks us for arc KL. Now KL is this arc over here. Again, I'm kind of using the same idea. This is a half circle from K to N again. I know this is 40 and 25, and that's 65 together. So if I take 180 minus the 65, I should have the arc KL. And that's 115. Again, that's still a minor arc. Arc JM goes from here to here. And it doesn't specify which way to go, across the top and or across the bottom. The shortest distance is equal to the same there, but it doesn't matter since it's half a circle, and half of a circle is 180 degrees. The word for half a circle is semicircle. JKN, so I need to start at J, I need to end at N, but I have to go where K is in between, so it's this arc. So from J to M is 180 degrees, that's a half circle, and I just need to go 25 degrees more. So JKN is 180 plus 25, which is 205. That's more than a half circle, so we call that a major arc. And the last one, LMK, goes from here to here. Now we can add all these little pieces together. I know this is already 180, and this is 65. So I can do 180 plus 65. And that's 245. Again, that's a major arc. Number 2, it says the lines there that look tangent are tangent, and I'm supposed to solve for x. Well, here's a tangent line. And anytime a tangent line meets a radius, it forms a 90-degree angle. This is another tangent line, and if it meets the radius, forms a 90-degree angle. So what we have is a four-sided shape. All four-sided shapes should add up to 360 degrees. So I'll take 117 plus the 90 from there plus the 90 from there, and that's 297. And I'm going to subtract that from 360 because all four-sided shapes add up to 360 degrees. So x has to be 63 degrees. For number 3, I need to find the measure of all the angles and all the arcs. These are not center angles. They don't go through the center of the circle. All these angles here, A, B, and C, are inscribed angles. And inscribed angles are equal to half the measure of the arcs. So whatever arc they make, the inscribed angle is half of it. So for example, arc BC is 120 degrees. The angle that makes arc BC is this one, this angle that's angle A. So angle A should be half of 120. So angle A is 60 degrees. Using that same idea, but this time I'm given that angle B is 30 degrees, and it forms that arc AC. So I know that the arcs are twice as large as the angles, see 60 and 120. So this arc should be twice as large as 30, or that arc AC should be 2 times 30, which is 60 also. So that part's 60. I also know circles are 360 degrees. So across that top, 60 and 120 is already 180. So if I take 360 minus the 180, I get that arc AB, the arc across the top, is 180 degrees. That means AB goes right through the center of the circle, because the AB would be a semicircle. And the angle that forms that arc is angle C. So angle C should be half of 180, which is 90. For number 4, I'm supposed to find the arc length from here to here. So this is the arc length from A to B. So to use that, I need the arc length formula, which means I need to take the measure of AB, the measure of the arc, out of 360, and I should multiply it by the circumference, since I'm trying to find the distance around the circle, which is pi times diameter. So 150 over 360 times pi. 18's our radius. So now we need a diameter, so we need to do 2 times 18, which is 36. So I just simplify that. If I want to leave it in terms of pi, this is 15 pi, and if I wanted to get decimals, it's 47.1 inches. Number 5, I'm supposed to find the area of the sector created by arc JMK, which is this side here, the unshaded part. I want to find that area only. Well, I need the area of the sector form. I still use the measure of the arc out of 360 times, and since I'm looking for area now, I need the area of the circle, pi r squared here. They tell me that this arc is 50 degrees, but I need to know this one. So to get that, I can do 360 minus the 50. So this arc on the inside is 310. Sorry. So 310 out of 360 pi. My radius is 7 squared. If I multiply it all out, I get approximately 132.6 feet squared. And number 5, I'm converting from degrees to radians and radians to degrees. So I need to make sure I remember that the key conversion rate is that 180 degrees is equal to 1 pi radians. And that's what we need to use to convert. So 105 degrees, well, let me set up a proportion. I know that 180 degrees is the same as 1 pi radian. So let's use the proportion. The 105 should go at the top because it's degrees, and then x should be on the bottom because that's radians. And so we cross multiply. So that's 180 times x equals 105 times pi. And I divide by 180. The thing about radians is that you need to keep your answer in terms of pi, and also if you need to leave fractions, if you need fractions. There's no decimals in radian measure. You should leave your answers exact like this. So let's reduce 105 over 180. Well, I can divide both numbers by 5. So I can divide the top by 5 and the bottom by 5. 105 divided by 5 is 21. 180 divided by 5 is 36. And then I see I can also continue dividing both numbers by 3. 21 divided by 3 is 7. 36 divided by 3 is 12. I have to stop there because I can't divide by 7 by anything and 12 by any other number. That's the same. So I'm done there. In part 2, I need to convert this radian measure into degrees. So this is a little easier because I know that pi is equal to 180 degrees. That's the conversion rate. So instead of pi there, I'll go ahead and just substitute 180 degrees. Then 16 divided by 9 times 180 is 320 degrees. Number 6, I'm supposed to find the area of the composite shape. So I see two shapes here. I see a triangle, and then I see a half circle. In the end, I'm going to add these two shapes together because these two shapes are put together. The area of a triangle is base times height divided by 2. So the base on this triangle is 15. The height on this triangle is 15. And then divide by 2, I get 112.5. The area of a half circle, well, I know the area of a circle is pi r squared, but since I only want half the circle, I want half the stuff inside, I'll take that answer, take that pi r squared and divide by 2. So that's pi, your radius. This is 15 all the way across, so my radius should be 7.5. Squared over 2. That gets me about 88.4. So these are my two results. And since I'm going to add these two shapes got added together to form this shape, I'll add the two areas, 112.5 plus 88.4. And that gives me 200.9 feet squared. Over here, I see two shapes. I see a rectangle, then I see two half circles. Right? I have a half circle on the right that looks like this, and a half circle on the left that looks like this. And together, they should create a full circle. Since I have this rectangle and I'm taking the two half circles out, I'm going to actually subtract the areas. So the area of the rectangle is base times height, and in our case, that's 33 times 16. It's 528. The area of a whole circle, since two half circles form a whole circle, is pi r squared. The 16 here, that's our diameter. That's all the way across our circle. We want just half of that, so we want 8 squared. and that's approximately 201.1. And again, we're going to take these two results and we're going to subtract them. We subtract the area of the rectangle. Sorry, take the area of the rectangle, subtract the area of the circle. So 528, subtract 201.1. That equals, 528 minus 201.1 is 326.9 feet squared. On the back, we need to find areas of these following shapes. This is a trapezoid, so one could use the area of a trapezoid formula, except I just never I'm good at memorizing stuff, so I won't do it that way. I'll do it by creating two triangles. This is triangle 1 and that's triangle 2. So to find the area of triangle 1, well, it's just base times height divided by 2. And the base of that triangle is 10. The height of that triangle is 6. Divided by 2 gives me 30. If I look at the area of triangle 2, the base is 6. The height on that triangle is still also 6. It's straight up and down 6. And divide by 2, and that's 18. Afterwards, I can just add the two results, and I get the area of the whole trapezoid. I'll do the same thing for number 8. So I know there's a formula for the area of a kite, I just don't remember it. So I can create two triangles. I can create a triangle on the left and the triangle on the right. Looking at the triangle on the left, its base is this whole length, 11 and 9, that makes 20. Its height is 8, and if I divide that by 2, I get a result of 80 centimeters squared. Triangle 2 is this one over here, and that's exactly the same. This is a base of 20, a height of 8, divide by 2, that's going to give me 80. So 80 plus 80 together, so the whole area is 160 centimeters squared. On number 9, this is a regular polygon. So all the sides are 3.2, and then more specifically, this side is 3.2. So when I get this, I can create a triangle. I can find the area of that triangle. The base is 3.2. The height is 5.5. And I'll divide that by 2. So I get that area of that one triangle is 8.8. I just need to see how many more triangles I can create in here. It turns out there are 11 triangles in this shape. So I know the area of one of those triangles, and all those triangles are the same. So I'll multiply that by 11, and that'll get me the area of the whole shape. So 8.8 times 11 is 96.8 inches squared. And number 10 is very similar to number 9 in that I need to just know this height. So I need to solve for that height, and so the way I do that is I need to use Pythagorean theorem. This length is 9, so I need to go 9 squared plus h squared equals 23.5 squared. This is 81. This is 552.25. Subtract 81 from both sides, and then square root. I get of a height that's about 21.7. So again, if I find the area on that one triangle, area of the triangle is 18 times the height of 21.7 divided by 2. Is 195.3 for that one single triangle. And then I count, okay, there's 1, 2, 3, 4, 5, 6, 7, 8 triangles there. So I take that 195.3 and I multiply by 8. And that gives me a total area of 1,562.4 feet squared. Okay, so this is the review for chapter 11. We need to basically find the volume of these shapes. So this is a triangular prism because we have two bases and they're triangles. So with a prism, the volume is capital B H. Now capital B isn't just a number you just grab from the picture. Capital B is the area of the base. So you need to always find what shape your base is. And with this particular prism, with all prisms, you need to find a shape that's exactly the same, but on opposite ends of each other. So those triangles are bases. We need to find the area of those triangles. So capital B of those triangles is going to be base times height, 6 times 8, divided by 2, and that's 24. So the volume, capital B, is 24. Now the H, the height, isn't always how tall it is. It's just the length that connects the two bases. And in this case, it's 7. So 24 times 7 is 168. And that's our answer for number 1. Number 2 is a rectangular prism. So the bottom and the top could be your bases. And the front and the back could be your bases, the left and the right can be your bases. It actually doesn't matter on a rectangular prism. We're going to do the bottom. We're going to use capital B times H. So capital B in this case is 10 times 4, 40. So this is 40 times 12, which is 480 inches cubed. Number 3, the shape is a cylinder. So we need the volume of a cylinder. And that's still kind of capital BH, except our B is a circle. So the capital B just turns into pi r squared, and then H. So the radius is 6, the height is 10. That's, if you leave it in terms of pi, that's 360 pi. If you multiply that out, it's approximately 1131 yards cubed. Number 4 is kind of tricky. The bases are this shape, the front and the back. So this is a trapezoidal prism because the bases are trapezoids. So I need to find the area of those shapes. So in the area review, to do that we created two triangles. That's triangle 1 on the top and triangle 2 on the bottom. So we need to find capital B, takes us a little work. So we need to do the 1.6 times 2.4 divided by 2. And that gives us 38.72. And then this one, we should add it to there. That's going to be 3.2 times 2.4 divided by 2. And that's 3.84. Let me check the calculations in there first. I messed up here. I'll do this one over because that answer is completely wrong. 1.6 times 2.4 divided by 2 is 1.92. And we're going to add these together and get 5.76 as our capital B. So volume equals capital BH. 5.76 times the height connecting the two bases, which is this length of 3. So that's 17.28. Number 5 is a pyramid, and it's a triangular pyramid. So the volume formula for any pyramid is capital BH divided by 3. So the capital B, again, is a triangle. It's this one at the bottom. So I need to do base times height divided by 2. So this side is 9 times this side that's also perpendicular to it, because you see the right angle. 9 times 16 divided by 2, because it's a triangle. So 9 times 16 divided by 2 is 72. So that's my capital B. My height of the pyramid is 10, and I need to divide that by 3. So that's 240 meters cubed. Number 6 is a rectangular pyramid. So the volume formula is capital BH divided by 3. My capital B is just the area of that rectangle. So 4 times 7, which is 28. So 28 times the height of 9 divided by 3. And I get a volume of 84 feet cubed. Number 7 is a cone, and its volume formula is pi r squared h divided by 3. Now I have a radius. The radius is 9. I don't have an h. I have this 10. That's the slant height. So I need to use Pythagorean theorem to solve for this h. So on the side, I'll do h squared plus 9 squared equals 10 squared. 81 and 100. H squared equals 19, so h is the square root of 19, which I'll just round to 4.4. So now I can plug it into my formula. Volume, pi, your radius is 9, 4.4 divided by 3. And I get approximately 373.2 meters cubed. Number 8 is a sphere. So the volume of a sphere is 4/3 pi r cubed. So 10.8 is my diameter. That's all the way across. I only want halfway across because I want the radius. So half of 10.8 is 5.4. So 4/3 times pi times 5.4 to the third power is 659.6 meters cubed. So number 9 asks me to find the surface area of this cone. The surface area formula is pi r squared, for a cone at least, plus pi r L. Remember that L is the slant height. It's this height right here, which I do not have. So again, I'm going to use Pythagorean theorem to solve for that. So 22 squared plus 5 squared equals L squared. 22 squared is 484 plus 25 equals L squared. Combine these two and you get 509, and then square root to get the slant height. It's about 22.6. So the surface area is pi times 5 squared plus pi times 5 times 22.6. And you can just type all that in your calculator and get a surface area of approximately 433.5 meters squared. On number 10, that's a sphere. So the surface area of a sphere is 4 pi r squared. 30 is my diameter, so my radius is 15. So if you want to leave it in terms of pi, that's 900 pi, or 2827.4 centimeters squared. On the back, I have a composite shape there. It looks like a hemisphere, so a half a sphere, and a cone got put together. And we just need to add them. So the hemisphere, the volume of a full sphere is 4/3 pi times radius cubed. And since I only want a hemisphere, half a sphere, I need to take that result and divide it by 2. So if I do 4/3 pi times the radius of 9 cubed and divide the whole thing by 2, let's see, 4 divided by 3 times pi times 9 to the 3rd power is that, divided by 2 is that. So 1526.8. The cone is pi r squared h divided by 3. Pi, my radius is 9 squared, my height is 18, divided by 3. I type that in. I get 1526.8 also. So what I need to do is these two shapes got added together. So I need to add the two shapes together to get my final volume. And that'd be 3053.6 centimeters cubed. So this picture looks like a cylinder, and it looks like it got 2 hemispheres taken out of it, or 1 whole sphere taken out of it. So I'm going to need to subtract like a whole sphere. So I find the volume of a cylinder first. That's pi r squared h. The radius is 6, the height is 15. And that gives me 1696.5 approximately. Then I need to find the volume of the spheres. And that's 4/3 pi, and then the radius is 6 cubed. And that gives me 904.8. Those are my two results. And since I'm taking the hemispheres out of the cylinder, I subtract my two results. I'll take 1696.5, subtract 904.8, and get 791.7 feet cubed. So number 11, these shapes are similar. I need to use that to find the volume of B. Well, I know this is 10 and this is 24. So let's compare 10 over 24. And we're going to make a comparison using volumes. This volume is 160. This volume we don't know. So the 160 should go with the 10, and x goes with what we don't know. So just be careful about this. We're comparing volumes. So when we compare volumes, we need cubes here, because volume is to the 3rd power. Okay. So this is 1,000. 24 to the 3rd power is rather large. It's 13824 equals 160 over x. And we're going to cross multiply. So that's 1,000 times x equals 160 times that, which is 2211840. And if you divide by 1,000, you get that the missing volume is 2,211.84 centimeters cubed. And lastly, the second number, 12. So manufacturer needs to fit 6 soccer balls in the box for shipping. So they're in 3 columns of 2 balls each, so kind of like this. So you have to kind of use your imagination that these are the soccer balls from bird's eye view looking straight into the box. They tell me each soccer ball has a radius of 4. The box fits just around the balls as closely as possible, and we're supposed to find the volume of the box, the balls, and any wasted space that there is. So I think the easier thing is to find the volume of one ball. And the ball is basically a sphere. So that's 4/3 pi r cubed. They tell us the radius is 4, so I can just plug that in. So the volume of one ball is 268.1 approximately. But there are 6 balls. So if I multiply it by 6, that gives you the volume of 6 balls altogether. And that's 1608.6. Now I need to find the volume of the box and the wasted space, the space not taken up by the balls inside the box. So if this is 4, that means all the way across here is 8. And there's 3 balls across, so that's 8, 16, 24 here. And again, this is 8, because the radius is 4, and this is 8, so 8 and 8 make 16. And there's only one layer of balls in there, so this distance must be 1 ball across, so that's the diameter of 8 there. So we need to find the volume of the box, and again, that's capital BH. Capital B is the area of the base, so the 24 times 8, which is 192, times the height of the box, which is 16. So the volume of the box is 3072. The volume of all 6 balls is 16.08.6. To get the wasted space, we subtract those 2 numbers. So the volume of the wasted space is 1463.4 inches cubed.